Alright, so here what we have is another problem involving the fundamental theorem of calculus, but this problem is a little bit more challenging, I would say, than the previous one that we just saw. Here we're asked to, or we're told, I'm sorry, that the integral from 0 to some value of k of this function right here is equal to 18, and what we are asked to do is, given this information, can we find k? Well, we're going to use the fundamental theorem of calculus and some algebra to go ahead and figure out what this value of k is. Now, what I'm going to do is just evaluate this integral as if k was just some constant. I'm really not going to pay much attention to what k is at this point. I just want to find an antiderivative of this thing here. So let's go ahead and do that. So the integral from 0 to k, and we have our function here 2k x minus x squared dx. We know that this is equal to 18. That's exactly what they tell us up here. Well, I'm going to find an antiderivative here. I'm going to start with this first term here. So the antiderivative of 2kx, the antiderivative of 2kx is going to be, well, it's going to be kx squared. And you can go ahead and check this by taking the derivative of this. And if you take the derivative of this, the 2 would come to the front, and you would have 2kx to the 2 minus 1. And 2 minus 1 is 1, so that would leave you just with 2kx, which is exactly what we have here. You can think about just applying the rule, the power rule for integrals, which says that you add 1. So I'm going to add 1, so 1 plus 1 is 2. And then I divide by 2, but notice the 2's here will reduce or cancel out, leaving me with just kx to the second power. So that's the way you can do it if you want to go about it the long way, or you can kind of just think about 2x squared, and the antiderivative of 2x squared would be x squared, and you can figure it out from there. But let's go ahead and continue here with this one. This term here, the antiderivative of x squared, again we add 1 to the power and divide by what we get, so we're going to have 1/3 x cubed, and this is going to equal, we know that this should equal 18. However, because we evaluated this antiderivative, we have limits here, and the limits that we have go from 0 to k, and this right here is the fundamental theorem of calculus that we're going to go ahead and use. So I have to plug in my limits wherever I have an x value. So it looks like I'm going to plug in my k first, and then I'll plug in the 0. So I end up having something that looks like this. So I have, let's see, k, and instead of x squared, again, I'm going to plug in my upper limit. My upper limit here is a k, so I'm going to plug in k. And then I have minus, here's my second term, so 1/3. I have an x there, so again, x is going to get replaced by my upper limit, which is again, oops, I wrote a square. That should be a cubed. And I'm going to go ahead and plug in my upper limit again, which is k. So again, this is my f of b. This is my f of b. Next comes my f of a, and I have to subtract the two. I have to subtract. So now I'm going to plug in 0. And so if I plug in 0, I will have, let's say, k times x squared. But remember, x is getting replaced by my lower limit now, 0. And then we're going to have minus, let's see, 1/3 x cubed. But again, remember, x cubed gets replaced with my lower limit, so it'll be 0 cubed. I can close this. I can close this off. And we know that this should equal 18. So what we have now is just an equation to solve for k, and we're practically done. The calculus part is over with. What we now need to work on is our algebra here. Well, if I look here, I have k times 0 squared, but 0 squared is 0, and 0 times k, well, that's just going to be 0. So this here will go away to 0, and similarly this here will also go to 0. So, well, what are we left with? Well, let me just scroll down a little bit. Give me some room there. Okay, so we have, let's say, k squared times k. This gives me k to the third minus 1/3 k cubed. Remember, all this here went to 0, so all that's left is that this is equal to 18. So here, remember, this is 1. We can think about that as 1k cubed minus 1/3 k to the third power. And so 1 minus a third, that is 2/3. 2/3 k cubed is equal to 18. And so what I can now do is just multiply. I can just multiply by the reciprocal. So I can multiply this by 3 over 2. I can multiply this guy by 3 over 2. And if I do that, then the 3's here will reduce, the 2's will reduce, leaving me with just k cubed, which is exactly what I want. And here I can think about 18 divided by 2. Okay, so 18 divided by 2 is 9. And then 9 times 3, this is equal to 27. So let me just go ahead and rewrite what I have. So let me just go ahead and rewrite what I have left. I have this k cubed on the left side, so I'm going to have k cubed is equal to, and then here 9 times 3, we said that is equal to 27. So that here, to solve this equation, you can take the cube root of both sides, or you can easily just do a little bit of multiplication in your head and just ask yourself, what number can I multiply by itself 3 times to get 27? Well, if you think about the number 3, 3 times 3 is 9. So 3 times 3 is 9, times another 3 is 27. So what I'm saying is that 3 times 3 times 3 is 27. And so we can think that 3 to the third power is 27. So we have our answer that k is equal to 3. Again, you could have also just, taken the cube root, and just kind of ask yourself, what is the cube root of 27? And you would get an answer of 3. So here in this problem, k has to equal 3.